Results of the simulation of relationships between predators and prey with note cards by Alison Burke, Sophia Falco, and Rohit Rajuladevi. Many animals have gone through predator-prey fluctuations. From the dodo bird to the white-tailed deer, this is extremely common in nature. While there are many other factors in predicting population, predator-prey relationships make up a large portion of the causes of change in populations. In our experiment, we decided to look at a simplified simulation of population, focusing solely on predator-prey relationships, compared to the individual populations of predators and prey. In our first experiment, we analyzed the population of predators and prey, where each predator needed 3 prey to survive. At the end of one generation, the amount of predators and prey were doubled, unless there were 0 remaining, in which the population was set at 1. The way we simulated this was through small square pieces of paper that represented prey, and large squares that indicated predators. A prey was eaten if a large square landed on it. We did this for 20 generations. The results of the simulation, where the predators needed 3 prey to survive, were interesting. We found that from the 1st to 6th generation, the population of prey increased dramatically, while the predator population lingered at low numbers. Then at the 5th generation, we saw a massive decrease in prey populations. This was due to the fact that the predators now had more resources and could reproduce at higher rates. Despite this, the predator population lingered at low numbers. This occurred because the predators were eating more prey than needed. Fluctuations happened again from the 8th to 16th generation, where prey ended up having a population of 26 until they decreased. We concluded that from the simulation that as the population of predators increase, prey decrease, and the number of prey increase when predators decrease. We used the first experiment as a control for our second experiment, where we asked ourselves the question, what will happen if predators only needed 2 prey to survive? In this simulation, we still maintained the same procedures as the first experiment, using the same amount of cards to represent prey in the beginning and predators, 1 to 3. We found that the number of prey and predators were very low and close to each other in this experiment. The predators were near the same population of the previous experiment, while the amount of prey decreased. This happened because the predators only needed 2 prey to survive and would eat the prey when they tried to increase from 1 to 2. But then at the 16th generation, the prey were able to escape the part of the graph where the rate of reproduction of the prey were equal to the food required by the predators. Because of this escape from this barrier, the prey were able to increase at high rates because the predators would not eat as many animals as the offspring produced. This happened at the end of 20 generations, so the population was still increasing largely. We do predict, however, because of the availability of food, the predator population would rebound at some point. This would happen at quick rates, because the predators would only need 2 prey to reproduce and double. This leads us to infer that the period between the rapid increase and decrease of prey is shorter when predators only require 2 prey to survive, compared to 3 prey to survive. The reason we infer this is because despite the fact that eating 3 prey kill more prey, the ability to reproduce at higher rates allows the predators that only need 2 prey to catch up quicker and stop the increase in prey populations. We also concluded that when the prey population increases, the predators require 2 prey to survive. The prey can reach populations higher if the predators ate 3 prey. What this means is that in the experiment, where 2 prey were needed to survive, the population capacity of prey were higher, but death occurred at higher rates than the control. Now, this experiment was a very good simulation. It wasn't as accurate in the real world because of how simplified it was, but it was good because it modeled the real ecosystem by showing the correlation between predators and prey populations. We
Created using Powtoon.